there's Portland, right? That's everywhere I've been in Portland in the last 3.8 years. But it's actually kind of boring for me because it's just location, right? Like there's no, it's just places. It could be a street map, basically, with like some thumbtacks on it. So let's bring time in. Everywhere I've been in 2011 is green. Everywhere I've been last year, yellow, then red, then blue, back 4 years. So when we look through time, we can start to see patterns that weren't immediately evident. Like, I used to live down here. Now I live up here. So you can see I've been drifting upwards through Portland. That might make you think about seasons. So over the last year, here's my activity by time of day. Incidentally, you'll notice I'm not labeling any of my axes. That's like a horrible sin, but it's actually kind of deliberate because I really want you to think about the relationships, the internal relationships in the data, right? The patterns. It doesn't really matter to me whether or not you can put this on a map and like invade my privacy and figure out where I am all the time. I want you to think about like what your map would look like, right? So no labeled axes, except this one. I lied. So you can see, for example, that in winter, January, February, March, I go out later, I stay in earlier, or I come in earlier, right? You can also see an anomaly here. October, November, December, there's this dip. That's not actually a dip, it's a hump to the right where I stayed out later because I was telecommuting, okay? I was keeping office hours, and every weekend I would make up for lost time and go outside and take a long walk. In the morning, I wouldn't go out at all on weekdays, except for lunch, which is that little this. So you can imagine how you can like slice and dice data by time to do any kind of pattern finding, like looking at your own behavior. So for example, I can look at my distance from home over time of day according to whether it's the day when I babysit my niece or not, right? And I can just pick it all apart. So I'm just zooming out now. You can see the kind of greater Portland area. There's Beaverton, there's Sovey Island, there's Milwaukee. I went there once 3 years ago, apparently. I don't remember what that was for. There's my grandma's. Okay, now we've zoomed out even further. Here's Portland down here. Here's, I guess, hiking by Mount Hood. Here's the gorge. Here's the coast again. And here's up into Washington, right? Seattle, Port Townsend, and the San Juan Islands where my family lives. You can see I haven't visited them in a year and a half. So you can imagine, I hope, like what your version would look like. No. However, you'll notice something funny about this map, which is that it's terrible, right? You can't see, it's all spread out, right? What we want to look at is what I do most often, or what I want to look at is what I do most often. So I was looking at this, a version of this, and I remembered when I was little, I used to make these maps where I would take like a 8.5 by 11 piece of paper, and I would draw my room in the middle, taking up like half the area of the page, and then I would just draw everything else I knew about or cared about or had been to or wanted to go to around the edges, like kind of getting smaller and smaller as it went out. So you'd have like my room in the middle and then like North Pole, South Pole, you know, like Europe, Asia, like that, right? So I thought, why don't I just do that now that like, you know, I'm old and get to use computers. So here's a log scale graph. Only instead of log on like the vertical axis, it's log according to distance from a coffee shop where I spend too much time here in Northeast. So this is the same data, right? This is all the same points. All the same elements went into this. It's all, I think, 3.25 million points in this, Same data, different projection. So this kind of approximates how close things feel to me, right? Like if I'm here at home and I walk to like the mall, it doesn't seem that much further to then go downtown. Even though if you look at it on a linear map, it is, right? So this is just, I guess the best way to put it is to say this is how I think of space when I'm not thinking of it spatially, right? In terms of actual space. And you can see like that huge trip into Washington doesn't seem that much further than, say, going to the coast, even though in terms of real space, it kind of is. So we can look at things other than time of last visit. We can look at, for example, elevation. I'm really proud of this one because, as Aaron was saying, most GPS receivers' altitude data, right, your like, z-axis, is really terrible because of the way the satellites are set up. Like if you do it on a piece of paper, it's really kind of easy to explain, but the elevation data, terrible. So this like represents a lot of walking around and a lot of filling in and a lot of data processing, although this isn't the most processed version. But you can see like the big ridge in northeast because Rocky Butte is there and there was an enormous flood thousands of years ago and that's like the sandbar that filled up behind it. Or Mount Tabor. And you can imagine how you can interpolate and then you would have a topo map which already exists, but it would be yours using things that you would like personally been to. Velocity. So you can see, for example, highways, and then a lot of walking. Walking is obviously bluish, driving is reddish, fast driving is yellowish. There's some train up there too. You can play with this. I could do like a 20-minute talk just on velocity data. Like it's a lot of fun. But let's look at the direction I was going last time I was there. Okay, so if you think of the color wheel, right, and then you just color a point according to which direction you were going, according to the color on the color wheel, that's this. So you can see, for example, I was going kind of north here, that's reddish. I went clockwise around Soviet Island, so it kind of makes a color wheel. But again, you'll notice it sucks, right? This is terrible. You're not seeing anything useful. So let's throw away latitude and longitude entirely. Okay, so now we're using GPS data, but we're not using the two things that everyone uses GPS data for, latitude and longitude. We'll just throw it away. Here's kind of a weird plot. So distance from center is how fast I was going. Okay, it's square root scale just to make it easier to see low values. Don't worry about that. Distance from center is how fast I was going. Angle is angle in the real world. So over here, I'm going northeast fast, right? Over here, I'm going southeast slowly. So let's look at these different patterns. This inner one is walking. And you can see these little like nodes on the cardinal directions. That's because I do a lot of walking on a street grid. Even more directional is the data for driving. That's these lines. Okay, that's city driving. More directional, sorry, less directional than that, is this kind of vague ring. That's highway driving. And it's mostly north-south because I drive on I-5 more than I drive anywhere else on a highway. And then just outside that, there's the train, which is a little bit faster than highway driving. That's like 80 miles an hour as opposed to 65 or whatever the speed limit is. This leaves us with a mystery, which stumped me for a while, which is this ring. Okay, there's something I do that's faster than walking. It's slower than driving. Watch what I did to figure this out. Ooh, the color's not really coming through. But the gist of it is red things are happening in Oregon, green things are happening in Washington. Of course, yellow is the overlap, right? So we can see a couple of patterns. You guessed it. You can see a couple of patterns, right? One is that I don't walk on a grid as much in Washington because there's no street grid up where I spend most of my time in Washington. I do much less driving in Washington, same kind of reason, etc. Like, as you can see, I don't have any sophisticated tools to show off, but I really like this kind of data, and there's a lot of it out there, right? Like with geoloci and with like there are 5 billion phones in the world, right? And they all at least know the closest cell tower most of the time. We're generating a huge amount of this kind of long-term data that's not just where I am, but where I've been for years. And we're throwing most of it away, but it's really interesting. But I don't know what's interesting about it yet because I've only done like, I don't know, like 40 hours of total work on just doodling visualizations. But it's really cool data. So I want to encourage people to get into thinking about it, like location over time, like macro scale motion of humans. It's just fantastic. So like this is just the first 6 things I thought of that were kind of fun. that involve this kind of long-term data. I have this crazy scheme. If anyone is into, I don't know, medical imaging and or trigonometry and wants to play with GPS data, I have a crazy idea that just might work. Questions? Okay. Here's the utterly bananas 3D Skyview data idea. So you're a GPS receiver, and you're looking up, right? And you see a bunch of moving satellites, right? Basically in every part of the sky except a little half circle over the pole. Think of, okay, so say I'm a GPS receiver, and I see 8 satellites, okay? Imagine that instead of thinking of them as satellites, I think of them as an image with 8 irregular pixels, okay? Now, most like non-super low on GPS receivers will tell you how good the signal strength is for each satellite. So like if you have a phone that has a little, like circular, like crosshairs GPS satellite view, it'll like be colored in with color, with, like green for a good signal, red for a bad signal, that kind of thing. So you're looking up, you see these, it's this low-res picture, and it's a picture of the sky, but not at visible wavelengths, but at GPS wavelengths. Now we have 3 different like fisheye sky views, right? These like fisheye low-res pictures of the sky. Now, let's change domains here. You know Microsoft Photosynth, where you take a bunch of photos of something from different angles and then it builds a 3D shape? That's the kind of data we're looking at, right? So imagine there's like a water tower here, and we take these readings with GPS receivers from 3 sides. We should see its shadow on the sky, sort of, like its image from 3 sides. And if we know enough trig, we should be able to fill it in. We should be able to say there's a shape of roughly this shape right here. We should be able to figure out where hills are on the horizon. We should be able to figure out where trees are. It's crazy. I said that up front. You can't blame me. It's crazy. But it's really, I really want to do it. So if anyone is interested in that kind of thing, because it's also, as well as Microsoft Photosynth, is a lot like something they do for CAT scans, maybe not CAT scans, various kinds of medical imaging called filtered back projection. And if you Google that, it's actually like a pretty simple, straightforward concept where you just take a stack of images and subtract them in a certain way. But you would have to deal with projection instead of having a like columnated. I don't know enough trig. That's the short version. And it is crazy. I warned you it was crazy. No one could say I didn't say it was crazy. Any other questions?
So if I wanted to find out more about your work or your play, are you an academic? Are you a researcher?
No, I'm just an underemployed nerd.
Okay, cool.
Yeah.
There are jobs.
So would you be interested in posting to the web or posting?
Yes, but the problem is that
I mean, not your data, but maybe your techniques.
oh yeah, techniques totally. Most of the techniques are super obvious. I was going to say the problem is that like if you look at this for long enough, you can figure out all of my friends' addresses. I don't really care about my address, but like I don't have permission from like the however like 50 houses I've been to if I can let everyone know I go there. But like, I mean techniques, right? We're looking at like the ugliest Python script in the world, right? Like here's a thing that turns a thing into a rainbow, right? Like does the linear to like HSL style thing. And here's like, how to do a great circle. It's you could do this in half an hour if you know Python and have Wikipedia. But I totally would publish it.
Do you talk about this stuff on Twitter or on a blog or anything?
This is like just been a hobby, so I haven't really published anything.
Some cool visualizations. I mean, especially
Thank you.
the mandala thing with like the directional.
Here's the thing about that visualization. Okay, so I'm just dragging this out for as long as possible. So this took like 5 seconds, not 5 seconds, this took like 5 minutes to think of, right? And it's really cool, but it wasn't like a huge brainwave.
Right.
It's stupid simple, that's the thing. As far as I know, this image and this image, right? As far as I know, these are the only 2 images of this idea anywhere in the world ever. So this is just incredibly fertile, right? Like if you were watching this and had an idea and you do it, you'll probably be the first person to do it with like long-term GPS data. So it's just like, it's amazing how easy it is to do something that hasn't been done before in this area.